topic. Topic is again data management. It's basically, think of it as like a recap of the previous week. And we want to go a bit deeper, maybe explain more concepts, but hopefully we don't really spend a lot of time here. So we do have chapter 3, chapter 7, and chapter 9. Let's start ahead. I just grabbed pieces in the textbook, right? So because we already know about like data management, data quality, and a bit of master data. So we can go ahead and ask the question, so what happens without data management? Obvious reasons always, like information system within the enterprise cannot be interfaced. So there's no way for them to talk to one another. Hence, data is not shared between the information system. And as we go deeper, it basically explains that you're doing your own thing, he's doing his own thing. There might be a lot of problems like consistency, redundancy, and so on, which we would have more in the other slides. Communication breaks down and information gets lost. Again, I don't need to explain that more. Data is unnecessarily transcribed and rekeyed. The wheel keeps getting reinvented. It's like also when there's an available tool already, you don't need to build that same tool, right? You just use the tool. You don't just out of nowhere create your own Excel spreadsheet. You just use a spreadsheet. That goes along with data management. Like if a department in your company is already doing something similar to you, why not just adopt what they're doing, right? The competitive edge of the organization is reduced. The more information is not clear to the organization, the more is it harder for a department or the whole company to succeed. Let's say, for example, if let's say our department, School of Technology and Computing, is doing a good job, like doing a lot of contracts, getting a lot of good students. But if, let's say, the enrollment team is not doing their job, handling the calls, and don't have information of what the program is offering, that's another mismatch of information. And it would go vice versa if the enrollment team doesn't advise us of the problems or what the type of students we're getting calls of. Let's say, are there more international students? If they don't give us that data, we'll just maybe keep on making the programs fit for not international students, and then now it breaks everything down. Your competitive edge is gone. But if they're saying that, hey, we're getting more of like students from my partner school in Vietnam, for example, then we might want to focus that as well and take advantage, right? Frustration sets in as well. Because again, if you're like the boss and you see data, I want data on this and I don't see data on this. I want data on this, it's not consistent, right? And also I'm going to show you again more examples from, I tried to dig up my old worksheets from, it's not confidential, it's fine, from my previous works. But before that, let's move on with lecture more. So data management activities, basically you need coordination, someone to facilitate it, and the pieces of the pie, basically you have your information service, system development support, data management tools, data definition, I think that was last week, data management policy and strategy, and education. Always need to train people. And as we define more about the pieces of the pie, right? So information services should be the one keeping the knowledge base. The problem with most organizations is they hire one employee, and that employee knows a lot of things, whether technology or business process, and then when that employee leaves, and the organization did not do its job on keeping how things work, you lose a lot of things. Education, so if, let's say, you're a group of analysts, you keep having the same errors in inputting data or whatever, there must be some retraining, right? Or maybe if the policy is not clear, we should clear up the policy so that the analyst would have an easier job not to make mistakes. We already defined this. It's basically what the data, what we need as an enterprise, the data that we need. Data management tools, where we store data, database. Quality assurance and data models database schema is done by the system development support. like the database administrators. So what are the roles within data management? So information management is the bigger picture, and the smaller picture is data management. Information management talks about general things like the process, system management, business information support. But in terms of data management, it deals more of like the data administration, database administration, and repository administration. So information management could go with like business process, right? This one is more like transactional, master data, and others. So benefits of data management is, again, increased availability of information, improves overall efficiency and effectiveness. What is data quality? It depends on the intended use, which must be accurate, timely, relevant, complete, understood, and trusted. Accurate, meaning if you're subscribing to a stock market provider, data provider, they should be accurate, that it reflects the true valuation of, let's say, Amazon. Timely. Let's say they give you the correct valuation, but that was a day ago, so that's not timely. That's not useful for you as an investor. Relevant. We talked about this like way before. That's like, I'm asking for the hand size and give you the shoe size, and that's not really relevant, right? Complete gives you the whole picture, right? They just give you a number, but they should also give the breakdown if they can. Understood, they have the data definitions. You can understand what you are reading when you see that number and the definition decided. Trusted, this is something that the organizations try to build. Like they trust, let's say, Bloomberg, that they would provide 99.9999% accurate data instead of someone who hasn't built their reputation to be trusted yet, like a new player in the market. So impact of poor data quality, basically negative impact on customer service, revenue, and profit. So think of it like this. If you're also like working as a customer support, and you're trying to advise on your customer when there is wrong data that's being given to you. Let's say, I think we have this special promo. It's $10. Well, the special promo from the other department says it's $15. So now you have the trouble of offering $10 to that customer when in fact in your other system, which is the system that you should be following, is $15. So those are the problems that you might encounter. Causes of poor data quality: databases having inappropriate schema, errors being made on data entry most of the time. Like I work a lot with data entry, and this happens true all the time. Data decaying over time. Okay. C. We also have data being corrupted when moved between systems. So think of it as like, I want to move my MySQL database to NoSQL database, and if you just do it like without any structure or getting an expert to do that for you, to map the correct fields, you might get corrupted data once you move it. Or could either be because of compatibility issues. Even though both are SQL databases, but this has a different version. Let's say this very new version doesn't support like null values for some reason. Now you have a trouble of getting errors or corrupted data. Lack of understanding of the data when it's used. Yep. What else? So dimensions of data quality is basically completeness and correctness. Okay. Key factors for considering quality of the occurrence of data: input validation. Again, that's when someone inputs, for example, login page, only accept email address. That's a big example for input validation. Integrity should be when you input the data, it should not change during transit, going to the database or whatever. I mean, when I put my username and it for the sign up, when it goes to the database, it should still be the same data. Currency, we know that there's a lot of different currencies. Duplication, sometimes we need it, sometimes we don't. Inconsistency, definitely we don't want that. We want the same data that I'm seeing is the same in the master data or the database. So again, this just shows you how things are grouped: data quality, correctness, completeness, and left-hand side is your metadata quality. So you have to create your data model correctly. Naming, EDL quality, occurrence data quality, we have input validation, integrity, currency duplication, inconsistency. And another graph. I'll just let you guys look at it. Okay, let's move on, because I think this one, you will forget this as well. Improving data quality, I'll look at the database design, basically. If something's wrong with the schema, you look at the data, measure the cost of poor quality information, and the way you can measure that, like in our case before, so let's say we're processing a report. If the report, we need to grab, let's say 80 items to input there. If we get one mistake, that's basically less than 90% correctness right away. Or, I mean, 99%. But if, let's say, I got a report that I have to process 400 items for just one report, if I get one mistake, I can still have that 99% accuracy. If you divide 1 over 399, instead of 1 divided by 80, you'll get a lower accuracy rating right away. So that's a way to measure your data quality. Improving data quality, you clean existing data that you don't need, duplicate, inconsistent, improve the enduring information, create a cultural transformation that everyone should strive for quality and what else? Accuracy, right? Because if you don't have that cultural transformation, people will just go on their days. Well, I can hit the 90% accuracy every time, so I'll just do that. So that's bad as well. So now we move on to the topic of what is master data. Data is a consistent official set of identifiers, attributes, and hierarchies for core entities. So identifiers, attributes, so entity, attributes, yep. So to quickly give you a glimpse where you understand it right away, so master data is something like this, which we give structure. We have the column names, right? And we also have the table name, right? And give you a contrast on the left-hand side. This is called transactional data. So this is what you get every time, let's say, a customer purchased something. So you get this type of data all the time, right? This one is more like that's in place, that's being stored. I mean, you have that, it's where your database is and where you retrieve data if you want to read something, right? And this is what gets into, like the insert into, okay? So the structure for the 6 data layers: metadata, data about the data, reference data, transaction structure data, enterprise structure data, transaction activity data, transaction audit data. So reference data is basically referencing to your data models and data definitions, so you'll know what to do with it. Transaction structure data basically just gives you, oh, this should be for this customer and product data transaction, it always should have quantity, stock, description, unit price, total price. Whether I can have null or not, it should be defined as well, right? So enterprise structure data, think of like the corporate data model again, the bigger picture. And transaction activity is basically the activity itself, not the structure. Audit is, again, post-transaction, you want to check. So master data deals with these 3 stuff: the reference data, transaction structure data, and enterprise structure data. Okay, so we'll do with muddiest points. Oh, not yet, almost there. So how do problems with master data occur? We talk this over and over again. If there's silo, meaning isolated departments doing their own thing instead of like one centralized thing. But again, there's some problems, like you mentioned before, being too centralized as well. But then again, usually the companies need the same correct, accurate data when they pull it. So a good example from the textbook is a bank can send marketing material for a mortgage product to a customer who already has a mortgage with the bank, because marketing uses a different system to operations, and customer is defined differently in each system. So it's like saying, it's like sometimes you feel this annoyance when, let's say, you already subscribe to Spotify and you're still getting ads for Spotify. Think of it like that. So he's selling, let's say, a mortgage, but you already have a mortgage with the same bank, with maybe the same rate, right? Another good example from the textbook, two branches of a retail company can sell a product at different prices because there is no consistent management of prices. Again, we might have encountered this from time to time, like, hey, I thought you're offering coupon, and then, no, we're not. It's like, but it says here in your coupon that you sent out, and they say, no, we're not. So that's a problem. So how do we manage master data? Many different ways. But we do have the master data management, the MDM, right? But again, technology alone is not enough because there's a lot of human component for that. And basically, your MDM hub looks like this. There's a lot of system in place, and you have an input interface that all of them goes through your MDM, master data management. And basically, master data management will also synchronize other systems as well. So meaning, if let's say the salespeople already sold the mortgage, it would go here, update this one, and now it will update the other system in such a way that the marketing department would see, oh, we already sold the or provided a mortgage for this person. I don't need to call them. Okay? Let's see. So Madhya's point. What is the role of data management? Manage the master data and keep it synchronized with transaction, as we saw in the previous diagram. Data redundancy, we learned before in discussion board. Does it cause poor data quality? Again, depends on the case. Sometimes you want data redundancy just because for integrity reasons. You lost this database, you have something that to back you up. But again, there is sometimes that it's not good to have the same data, right?
There's also a performance case for increasing redundancy. Like if you have a cache, it's going to mostly replicate data that exists in your database.
Correct.
But you use very, very expensive components to make your cache really fast that you can't afford to do for your entire database.
So even though this is a different diagram, something like that as what he mentioned is what would update the other systems as well, your other cache, to basically provide data redundancy. Let's say the systems are different databases or different caches. May I say that data management includes MDM, and MDM is one subject area of data management that is basically about information related to a person, employee, or contract. It's a lot of theory, but we already know what data management is. But to define it again, if you say data management, it includes the architecture, the quality, the integration, the governance, security, warehouse, and everything that you can think of about data. But when you say about MDM, it's a smaller part of data management that's primary concern is about the primary objects relevant to the organization, global data. And this one, I'm interested in improving poor quality data. The textbook introduced 10 steps to improve data quality, but if the schema is used, how to improve poor data quality to good data quality in the huge schema efficiently and economically. I wouldn't say there's a good, I don't know if there's really a good approach to make it efficient and economical, because migrations or because again, migrations or restructuring your design cost a lot of resources just to do that, because again, even though you're just restructuring, you have to migrate stuff first and put it back, right? And you would basically need manpower to do that. And for my experience as well, when I was hired first as a contract, that's what I've done. Like, I just one of the tasks was to manually extract data line by line to another database, right? So that one is very inefficient, but no choice. But again, that would be less error instead of like creating a new technology that there's no solution right away. Okay, and now I'll give you some examples. You can go ahead with, let's see, this one. So this is not in any order, but I'm going to show you some examples. So when I was an analyst before, when basically we get a report from a stock exchange, publicly listed, we're not the one manually grabbing it. The system, we have like a web crawler, think of it, which goes through the application, just skip this process, basically goes through this application and tries to match with the analyst, basically gives the tagging and everything and puts it in their repository, and now allocates that to certain analysts. Let's say this analyst is senior level, he can process priority 1 or priority 2 companies. So let's just define a priority 1 or 2 company could be because it's so complex, like let's say it's a bank company, they have a different way to report their assets and liabilities. Or we have customers looking at those type of data, that's why we have to process it fast and very accurate. Or else someone will be pinging us to say, hey.
Affects your customer experience.
Yeah, definitely. So this is like the step-by-step of how to use the internal database. So again, if you're a data, let's say encoder, right? You basically have a login. And here's what the system would look like for us in the user interface right away. When I log in, I just click user allocated. I would see all the companies that I have to process. This is an internal tool. So they grab it from somewhere. And when I click it, that, let's see. Now I have to even categorize. What part is it? Is it financial? Is it textual? Support? Is this a feed type document? And then we also have to select and input data. Now you see the human error, like report date, receipt date, publication date, right? And a great input data validation for this example is because these are annual reports and most of these are historical, so you can do something on the back side, the back end side, that says you can never put a report date that's like future date, because everything is historical, right? So what else? So creating a company, even creating templates for them, that you need to create a template for balance sheet, cash flow, profit and loss. Let's see more here. So the interface would look like this. You have different rows with different color codings, and you input data here, right? And there's also an older technology when you can just click the PDF, and when you double click, it goes to your selected field. And as you can see here on the top, these are validation checks. So if this does not pass, it means you're doing something wrong. For example, it's a good example for this one. Let's say you can never have, for example, you have items, 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 and total, right? You can never have a total that is less than all the items here. So that's a validation. So on the back end, you would say, it should be that the total is equal to the items up above it. If not, throw an error to the data entry specialist to say, fix your input. Or you can override it. Because again, sometimes the companies report it in the wrong way as well. We have no choice. So we have to put it what they report. Like, be consistent and what you call that? Transparent. Yep. So moving on to this one. Another example would be data definition guidelines. So when we were, this is our like, on day-to-day, we have this on our second screen. Basically, when we encounter an annual report, this is from our database, okay? Meaning, when I open up my database, I have these fields, and then I would have synonyms. If let's say deposits, it should be bank deposits, the time deposit, whatever, right? If there's derivatives, you put it in short-term investment. So these are synonyms, and also gives you hints like, okay, accounts receivable. If you don't see it, you might see it in a different way how the company reports. It might be tagged as doubtful debts. And then as you can see, we also give out like the certain code for a certain data. Okay, let's show you some more. You also do have like a tracker before of like the list of company names that we get. This is, I would say, inefficient, but because it was project-based, it was basically just extracted from the system, gives us a list of companies, and also gives us the date and everything, and translator, which is me, and also it has a value as well if it's peak season or not. So peak season for us is like if it's like, let's say April is where company releases a lot like their reports, so that's peak period. And we have to process things faster. And actually, it's sad to say I don't have the, there's another worksheet that they give us, like your accuracy rating as well. It should be really good to show, but I don't think I have that. So another thing is data definitions, I think, as well. But I think this time around we were more specific to a high priority company, again, where most of our customers are looking at. So we already have fields and definition, and maybe there its own definition for this company that we have to capture. That's a small part. Balance sheet example. So let's go to the top. So again, it's just title and definition, and this is just the balance sheet part. Let's see other fields. So during our training period, it was like a lot of information to take in, and you would get a lot of mistakes as well, because you have to know like gap or whatever. And I remember they even give us training data for quite a while, so at least you would have a better accuracy once you're doing it live. And let me see if I think I have more. So this is another tracker from, let's see, the second company. And basically what we have to, let's go to the very top. What I have to log is the document ID, the data issue number that's tagged with that certain report, having more categories, and how many comments, meaning translation, did I do, and the priority, right? If we don't have the priority list as well, we might be ending up processing a lot of data that our customer is not looking at the moment. And aside from that, I think the last one I'm going to show you is basically I extracted our data definitions for our own dictionary base. So when we're translating, we're also updating this. This has a counterpart. We have what we call the Sys-Trans software dictionary, where we try to, let's say after next time, this doesn't make sense because let's say our customer couldn't understand our translation, or for some reason there's a better equivalent, we do update that in our database. But basically we do keep our own definitions as well. So it differs from China companies, Hong Kong companies have different ways, Taiwan companies, and even the QA feedback, again, that's why we have the training and stuff like that. So QA is when we go back and forth, when we say, hey, we're right, and they say, hey, we're right. And hopefully we are right, because if we're wrong, we get deductions in our points or production, and less bonus in that sense. Let's see, what's more here? Yeah, I think that's it. So I just realized now that as I was going through and teaching this course that I've been dealing with a lot of data definitions that I don't know that these were data definitions, but because I was just a low-level analyst, it's like, just do your job. Just do your job, right? You don't need to see the whole picture. Just focus on accuracy, focus on processing fast, make our customers happy. That's it, right? So, I guess moving on. We can take a quick break now so that we go with exercise, and then after, I'll give you 10 minutes, then go back, do just maybe 2 or 3 exercises, because now I want to focus on the exercise for building databases, and also giving you guys time as well to meet as a group. So, okay? So 10-minute break, and we'll be back with SQL exercises. And also, sorry, before that, anyone has questions? Okay, later, if not. Our second session now. We'll be doing exercises, SQL joins, string concatenation, and subqueries. Joins basically would give you a lot of help with your team project, and very useful if you're going to do interviews, because you have to know joins. We can start off with this very, very classic meme of joins. So in that meme, hopefully that sticks to your mind of how the joins are basically being given to you. Oops, I'll just put it down for a while. So left join is basically just one part. Think of this as just the left. Right join is basically on the other side. And if you inner join, you just get the intersection, which is the face. And full outer join is outside. Okay, there's also, but most cases in introduction, we only look for inner join for now, the intersection. Give that up. I don't know how it happened, but it's fine. So there's there's different type of SQL joins. Again, this is from W3 resources. We have the inner join, left outer join, right outer join, and full outer join. As you can see, inner join just returns a record that have matching values in both sides. So it's this one, the intersection. Okay. Left outer join returns all records from the left side that match records from the right. This one, right join is the opposite. Full outer join doesn't make sense really sometimes, because it's like you just selected all from the both tables. The syntax for this is basically your select keyword and your parameters, basically the column name that you want from table 1, and you would want to join from table 2. And now you want to complete the connection with this on keyword. So table 1 dot column name equals table 2 dot column name. Meaning if I have user ID from, let's say, customers dot user ID equals, let's say, courses dot user ID. So this column name should match for you to join it. So again, inner join on. This is the syntax for that one. Okay. We'll quickly move on to string concatenation. This is better for when you're showing your SQL query as a report or on other subqueries that you want. So let's say you have a select keyword and you have to also add another keyword called concat. This may differ in different database technologies. And once you have that keyword concat, don't forget to put parentheses and add the column names that you want to concatenate. Concatenate, think of it as just adding them together, putting them together, concatenate. So you can have first name, comma, space, this one, space, comma, last name. So now you have an output, let's say, as full name, right? And you would have an output with a column name called full name, and your rows would have the full name, meaning the first name and last name. So you can show it that way. Again, you need to mention what table are you grabbing it from. Again. So what else? Again, with concat as well, this is a very basic function in Excel. So if you've done Excel, that's super similar. Next is SQL exercises, subqueries. Yeah, I mentioned this last time. Is basically you focus first on this one. If it's too complicated, your first select statement, and the value you're getting from that, you use that to another, let's say, select statement. Okay, subqueries. You have a query inside the query. Okay, we now move on to our first inner join exercise. Everyone stands up. Please don't be with your team project group, because I'll give you time to be with your team project group. Go find another person who's not part of your team project. And let's start with, how can you produce a list of start times for bookings by members named David Farrell? And this is an introduction inner join. So if you go ahead and Google the syntax of inner join, you will get the answers right away. There's no added complexity to this.
All right, so start time.
From select start time, because that's what we want. It already gives you a clue here. Start time, it's column name from which table, cd.bookings. So that's why I ask people, why do you use cd.bookings? It's because start time lives inside of that table, okay, from cd.bookings. Now you start joining them with the inner join clause, and you can also use join, inner join, and now you want to ask which table. If you don't look carefully, there are already some teams that says, I do CD facilities because there's name and there's name, but it says members name. And again, if you extract a name here, it's going to be names of facilities like power plant, CDU, right? You want to extract names in the members table. So have to be careful of that. So again, inner join, so what table do we want to join? The cd.members, because we want to grab the member name there. And now we want to satisfy the condition with the where clause, with the first name equals to David and keyword. The other condition is we want surname to be equal to Farrell, because if you have an or, we'll definitely get a lot of start times that includes, let's say, David Beckham, right? Something like that. So that's a good introduction. So next, how can you produce a list of start times for bookings for tennis court for the date 2012-09-21? Return a list of start time and facilities name pairings, clue, name pairings, ordered by time. Another clue, ordered by time.
So start time is timestamp. Is that a date format? Is that a date?
Let's see if it did the date time.
It says
timestamp. You can assume it's a date format.
Okay.
Yeah.
Start time and facility name.
I think everyone almost got it, and most of them got it in different ways, which is good. We start off with getting the two column names from the expected result. Start time and name. Another clue is because you have start, as the name here. If you know the keyword AS, basically it will relabel your column name. So you should have start time AS start. So it will appear as this one. But then again, it's fine if you did not do that. That's
Yeah,
fine.
they wanted an alias.
Yeah, so that's an alias. And then now you would have grab it from the table booking. And that's fine even though the two columns are from two different tables. It's fine because you're going to do inner join anyway. So with the inner join, again, always the clue is look at your ER diagram if you have it. And now you see that they are connected with FACID with CD bookings using the FACID as your foreign key, meaning it's a primary key of CD.facilities. And now once you make that connections, there are several ways to grab the condition. Like I think this one uses this where start time equals, there's a curly brace, D, and then grab this 2012-09-21. So you can also do something like this one with like, but I don't know because this is a date and time, so I'm not quite sure. Maybe correct, maybe wrong, but the logic sounds good. Another thing that you have to think about is basically this date and time, they have value, right? So think of it's like 1, 2, 3, 4, 5. So think of the 2012-09 something, like 00.0. This one is 12.00. This has value. The later the date or the later the time, the more value it has, right? It's like what's greater than March, June, July, right? Same with that, with the timestamps. So thinking about that they can be sorted because they have value. You now can think about the where clause where, right, this 2012 whatever is should be greater than or equal to, where start time is greater than or equal to the 2012-09 whatever, and you have to limit that because we only want the same date with different time. So now you still call the start time that should be less than or equal to 2012-09. Now you grab this range, okay? And now you use the order by to order things up, and you want them to order in ascending or descending. Because if it's ascending, lower value to bigger value. Again, the later the date has bigger value, that's why we want ascending, okay? Correct. So oldest to latest, that's ascending, okay? Let's move on to the next problem. Let's see, last one, cool. Last one, how can you output a list of members, including the individual who recommended them, if any, without using any joins? So that's a clue, you don't need to use joins. Ensure that there are no duplicates in the list, another clue, we did that before, need to refresh your memory, no duplicates in the list, and that each first name, surname pairing is formatted as a column and ordered. Okay, that's your clue. I think let's wrap up so we can take another quick break and do other activities. So the first thing that you have to know about is you have a select statement, and the clue is it has to be member and recommended. That gives you a clue that we have to use labels again. So in our first select keyword, we want to give you concat. So again, put things together. We want to concat first name, last name, and what do we want to label them as? With the AS keyword and put member, so now you have this member name up top. Now when you hit comma to have your second column, now you would need to create a subquery, meaning another SQL statement, in this case another select statement. And you would want it in such a way that you select again first name, last name as recommender, okay? And now, how do you know if it's a recommender or not? You now enter a where clause. And now you would use a where clause that would basically evaluate this one and this one, if they're equal, And if they're equal, basically you grab recommenders if they have or not. You would produce that list. Okay? So if I show you a very quick table, like let's say Clark, there's Jason, there's David. So if I happen to have, let's say recommended by, let's say this is ID1, ID2, ID3. And I can say David 1 was recommended by Clark. Instead of putting Clark, I just put 1. Right? So that's how you try to, that's why in your ER diagram, it says that the recommended by column name or attribute has a data type integer that is related to the member ID primary key, which is an integer as well. Again, this is a very easy example. You have a list of names, there's IDs, and you say David was recommended by Clark, so I put 1. Okay? As long as you get the logic, you should be fine in working your way to how you get the SQL statement. And then once you got that, now you want to order them. Again, you order by. And even though we have an expected result, if they just say, I want it ordered, it could be ascending or descending. And that's it. And if you want solutions for this, again, it's week 5. I'll give you all the resources and where I grabbed it. And feel free to work on it more. Okay? And thank you. Yeah.
Thank you.
Basically, pgexercises.com.